Hi and welcome to Angles in Parallel Lines. Just before we start, a reminder that there is a notes chapter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. Okay, so what we're going to look at today is a situation where we have a pair of parallel lines and a line intersecting them both. And we're just going to look at what we can say about the different angles involved in it. And so all I'm going to do to begin with, I'm just going to measure each of the angles which I've colour coded the same. So I've colour coded two angles which are pink. So all I'm going to do is just to measure that angle which is in pink, and I've got 65 roughly for this one. Now if I go to the one up here, I can say the other pink angle is also 65. So both of the pink angles 65 degrees. If I were to measure the green angle, well, the green angle is going to be 115. And if I bring the protractor down again to this one, we're at 115 as well. So both of the green angles, 115. If we flip the protractor around and we measure the blue angle, well, the blue angle there is also 115, and if I measure the other blue angle, we are looking at 115 again. So the blue angles all 115. And finally, if we look at the yellow ones, well, the first angle yellow one there is 65, and if I bring it down to the bottom, we are looking at 65 again. And so the yellow one would be also 65 degrees. Now what is that telling us? Well, if we have a look, those angles are matching up in pairs, and the way that the pairs work, if we look at the pink angles, I've got this angle here and I've got this angle here, and what they've done is they've formed an F shape. So the two pink angles have formed an F shape and they are both equal to each other. If I look at the blue angles, well, the blue is this one and this one, and this one and this one, and all that has done, that is forming a reverse F, and they have the same angle. Now if I get rid of those, I can also show you the green. Now the green is this angle and this angle, and once again we have that F shape, it's just upside down this time, and exactly the same works for the yellow. And so if we find this F shape with a set of parallel lines, we can say that the angles here are equal to each other, and that is because of a simple rule. It is called corresponding angles, and corresponding angles are equal. Why are they called corresponding angles? Well, that is because if I move this straight line, I can keep moving it and the angle is not changing at all. And eventually, as I place it on top of the other parallel line, well, it becomes the same thing. So they correspond to each other. And no matter where I move this line, those angles are not changing as long as I keep it parallel with the other one. So let's put that into action with a couple of questions. So we're trying to find the pink angle in each case, and all we need to do is identify whether or not we have that F shape. And so the angle that we know is here. The angle that we want to know is here. Do we have an F shape? Well, we do. It's just a backwards F, and therefore this angle and this angle must be exactly the same. It is 120 degrees. In an exam, we'd normally be asked for a reason as well, and so we will just state corresponding angles are equal. In the next one, the angle that we know is 55 degrees. The angle we want to know is this pink one. If I join them together, once again, I have that reverse F, and therefore this angle and this angle must be equal, and so that is also 55 degrees. In the last one, the angle that we know is 75 degrees. The one I want to know is here. Now, unfortunately, that does not create an F shape, and therefore what we're going to have to do here is just think carefully about how we can create an F shape, and that would all come down to forming that F ourselves. Now you might not see this as an F, but actually it's a backwards upside down F. And so this angle is 75, meaning that this angle is also 75. But that is not the angle we are actually looking for. The angle we are looking for is the pink one. But what we can say is that they form a straight line. And so in this case, we need to think about our rule about the angles on a straight line, and that is that they will add up to 180. And so in this case, I'm going to have to take away my 75. And so the angle I'm looking for is actually 105. And in this case, the reasons for my answer is that corresponding angles are equal, but also that angles on a straight line add up to 180. And we would need to give both of those reasons for this question. Okay, so next we've got again a pair of parallel lines with a single line intersecting them. But this time I've only highlighted 4 of the angles, the 2 pink and the 2 blue. And all I'm going to do again is I'm just going to measure those angles. So my pink angle here is at 65 degrees. And if I just check the other pink angle and measure that one, well, my other pink angle, I'm at 65 again. So both of my pink angles are 65. And if I then were to measure the blue angles, I'll just bring my protractor back in again, get this lined up properly. There we go. So blue angle is at 115. And if I turn it round, what about for the other one? Well, the other blue angle, that one is also 115. And so both of my blue angles are 115 degrees. Now, we saw this previously that we ended up with equal angles. Why is it in this case? Well, if I show you how we formed the pink angles, it was this angle, and this angle. And it's formed, what we can see is a Z shape. With the blue angle, it's there, and there, and there. And again, that is also a Z shape. They're just the reversal of each other. And that is because if we ever find a shape that looks like this, then the angles on the inside of that Z shape will be the same. And that is because of the rule alternate angles are equal. So if we see this Z shape within the parallel lines, we are dealing with alternate angles and they are equal. So let's give that a go. Again, all we're doing is trying to identify whether the angle that we have and the angle we want to know are forming that shape. Well, this is the angle I want to know, and this is the angle I already know. They are most certainly in a Z shape, and therefore there is 117 degrees again, and we would say because alternate angles are equal. In the next one, we could actually use the corresponding angles rule here, but I just want to show you how the alternate angle method works. This is the angle that I want to know. What is it alternate to? Well, it's alternate to this angle, and so it must be exactly the same. Now the key here is that if we think about these two angles, they are vertically opposite angles, and vertically opposite angles are also equal. So this one must be 80, and then because of the Z shape, this one must be 80 as well. And finally, we've got our parallel lines. The angle that we want to know is here. But this one, I can't form a Z shape at all. And therefore, I'm going to just do a quick erase. And I'm going to make a Z shape for the alternate angles with the angle that I already know. And therefore, this one must be 85 as well. The two angles which are alternate to each other are 85. The key then is that this is a straight line. and therefore these two angles must make 180, and so I've got 180 take away 85, which is 95 degrees. The angle we were looking for is 95, and again in this case we would have to state our rules that alternate angles are equal and angles on a straight line add up to 180. And so finally, once again, we have our pair of parallel lines. We have a line intersecting them both, and then we have pairs of angles which are highlighted. So in this case, the pink angles. Again, I'm going to measure those pink angles and just see what we can say about them. And so the pink angles, if we just turn this around, well, we get that the bottom pink angle is 115 degrees. And if I measure the top pink angle, I'm just going to have to take my protractor up to the top and rotate. Well, that one is at 65 degrees. And so, what can we say about those two angles? Well, let's not think about it just yet. Let's try the blue angles. And so my blue angle, again, I have 115 for one of my blue angles. And if I rotate it for the other blue angle, I've got 65 again. And so what can I say about those? Well, let's add them together. 115 plus 65 is 180. 115 plus 65 is 180. And so this time, the pairs do something slightly different. My pair of pink angles add 280. My pair of blue angles also add 280. Now, why is that the case? Well, in this case, it's a third and final rule. If we see a C shape, the angles on the inside of that C shape are going to add to 180. You can see we've got it there, and we have it here. And this is for the rule, co-interior angles add up to 180 degrees. And so if you see that C shape, you're going to look for co-interior angles. The ones on the inside will add to 180. So let's give that a go using a larger problem. So we've got a pink angle, a green angle, a blue angle and a yellow angle that we want to find with reasons for each one. And so we're going to go in the order that they have come. So we've got the pink angle is the one we want to find. So the pink angle is here. Now, if I have a look at the pink angle, can I form a Z shape or a C shape or an F shape? Well, if I look, I can actually form a Z shape with the 82. Now, given that that is a Z, it tells me that it must be 82 degrees. It must be equal. And the reason a Z shape is alternate angles. And so alternate angles are equal. The green, well, if we have a look at the green, here is the green angle. Now, what does that work with? Well, the green angle, we could think about just an intersection here and therefore vertically opposite angles. We could also, at this point, be thinking about using an F shape. So it makes an F shape with the pink angle, and therefore it must be equal to the pink angle. It must also be 82 degrees, and this time because corresponding angles are equal. In the blue and the yellow, we need to think really carefully about this because we haven't got a lot of information here. But in terms of the blue angle, here it is. In terms of the yellow angle, here it is. Now, there is one thing that I can say about those two angles. they have formed a C shape, so they must add up to 180. And so that might be one way that I'm going to get these answers, but beyond that, I need more angles before I can get there, because right now I don't have enough information to find either the blue or the yellow. And so I'm actually going to find an extra angle here. We know that this is 82 degrees, and we know that this one is 28 degrees. Now, together, that makes 110 degrees. Now, there is a rule that we can use here because we actually have a triangle. We have a triangle, and the angles in a triangle must add to 180 degrees. And therefore, 180 take away 110, well, that means that this angle is 70. And so my yellow angle, well, if we have a look at that, the yellow angle is a vertically opposite, and therefore that one is also 70 degrees. And that is because vertically opposite angles are equal. And then finally, the blue, we've already said that they must add up to 180, therefore 180 take away 70, well, that is 110, and so the blue one must be 110, and that is because co-interior angles add to 180 degrees. And so we end with the exam question. This came from the Edexcel paper in November 2018, and it was on both the foundation and higher paper 2. And we are told in this situation that BEG is a triangle, ABC and DEF are parallel lines. So work out the size of angle X, give a reason for each stage of your working. So this question is quite a difficult question. Especially in this situation, but what we've got are parallel lines, so that is important. The fact that we've got parallel lines, as soon as we have been told parallel lines, we want to be thinking co-interior angles, alternate angles, corresponding angles, and seeing if we can use any of those within the question. And so straight away, I need to just spot, I've got a parallel line here, and a parallel line here, and a line which intersects them. And therefore, I can say that this angle and this angle must be equal. So, how am I going to work out anything else from this question? Well, at the bottom here, it's a straight line. We were told that, and we were told, therefore, that this must make 180 degrees. The three angles which are forming the straight line must make 180. Therefore, 110 plus 25 is 135 degrees. And so let's subtract that from 180 and we get 45 degrees. Now, this is a stage of my working, so I need a reason at this point. And therefore, I'm going to write down angles on a straight line add up to 180 degrees, and so this is telling me that this angle here is 45. Now, the Z shape that we have drawn in here is telling me that this angle must be equal to this angle, and the key here is that that angle is formed from 45 and the 25, so that is 70 degrees, and therefore the angle at the top must also be 70 degrees, and therefore we need to give a reason for our stage of working, and so the 70 degrees because alternate angles are equal. And then we are trying to find X. Now X, we were told at the very start, well, that is part of a triangle. And therefore, what we need to start thinking about is how can I find the other angles in that triangle? Well, I already know 1 is 45, but I'm going to need this angle as well. And how could I get that? Well, again, we have a straight line. And so this one has 70 plus 35. So that is 105 degrees for the two angles we already know. Therefore, 180 take away 105 is 75. And so this angle is 75 degrees. And therefore, to get x, we are then going to need to use the fact that it is a triangle. And so, in that triangle, we have an angle of 75 and an angle of 45. And so that is 120 degrees. 180 take away 120 is 60 degrees. And therefore, the last little element, 60 degrees is the correct answer, but we also need a reason, and that reason is that angles in a triangle add up to 180 degrees. And so we have found the value of x.